So we are pretty much right on time. So I'm going to jump into scaling your algorithm with HyP. And I'm saying with HyP right now, but what we're going to build is a HyP plugin, which is just a Docker container that will run a workflow. It's fully portable. It doesn't have to be run in HyP, but it's using kind of the HyP style interface and best practices. So we'll talk about those later, but if you want to take a HyP plugin and you want to run it somewhere else, like on an HPC center or on your local laptop or whatever, you're fully able to do that. You don't get locked into HyP at all on the plugin level. We actually have a few people running our NISAR burst algorithms in GitHub Actions because bursts are small enough to just process there. It's kind of funny. So we're going to jump into a live example, which you guys can follow along with if I can get my code. So I'm going to hop over to Jupyter Lab. If I can. So this is about where we were yesterday. So we cloned the ASF OpenSAR Lab Wetlands notebook repo. There's a bunch of stuff done with that. Here, let me zoom in a little bit for. Yeah. You know if I need to zoom in more. So that repository is here in the file browser. And it just had an environment YAML and our notebook that we played with a little bit yesterday. So I've got a handy git alias that gives me kind of this tree view of what's kind of the git history. So there's kind of the master branch that we're on right now. So head is where we're currently at, pointing to master. There's some history. Develop branch is way behind. And then there's a feature branch that's out there as well. So what I'm going to do is we're going to run what's called the HyP cookie cutter. And a HyP cookie cutter is effectively a way to, or cookie cutter itself is a way to make templates of effectively repositories. So like GitHub, whole GitHub repositories. So documentation in the cookie cutter as written is assuming you're starting completely from scratch from an empty repository. So we're going to diverge just slightly from the instructions so that we can inject this cookie cutter directly into here. But first, I'm going to do a couple things in GitHub to sort of clean up some stuff, because what's going to come with the cookie cutter is some pre-built CI/CD actions, so you don't have to think about it. But there's a couple things that they expect. So in the Wetlands notebook, the first thing we have, oh, and I actually don't have write access to this one. So let's hop over to my fork. So all of you will likely have the same thing. So you'll have, if you're going to actually mess around with the GitHub settings, you'll need to fork it. So the first thing I'm going to want to do here, and I've done this already here, is in the general settings, I want the default branch to be developed. So when we take external contributions or open a PR, I want them to come to develop first so that they can be tested before we release. So we're going to use the main branch as the effectively the release branch or the stable branch. So I'm going to just switch that to develop, and then I'm also going to go to branches, and I'm just going to rename master to main. So GitHub will let you do this by just typing the edit button on that. When you first come to this settings page I was at, it will have said master. If you click this button, you can rename it to main, Git will handle all of that for you. And then you can also click this button to switch to another branch. So that means we've got main and we've got develop. Everything PR is going to open to develop by default, and then we're going to merge to main manually to release things is kind of the idea. So you'll actually see this happen. One of the things that we want to set up from here is we don't want people to accidentally delete these two branches that we're using to trigger all of our CI/CD rules and pipelines and deployments off of. So we can create a rule set. So this is a branch protection rule. So I've just called it primary branches. I'm not letting anybody bypass this. And I'm protecting the default branch. So that's develop. So that's a special branch, and the main branch. So you can see it applies to the develop and main branch. And then I'm not letting users delete it. And I'm requiring a pull request before merging, and you can't force push it. So I'm saying you have to make a pull request and you can't override it. And I'm not allowed anybody to bypass these rules in my fork. So that is how we enforce our CI/CD process. I expect a PR to open, it's going to trigger stuff. When a PR just merges, it's going to trigger other things, including a deployment. So I want to force you through that path. Other settings that you can mess with, this is controversial if you know Git. I actually turn off squash merging and rebase merging. We've sort of built our workflow assuming you're just doing the default merge commit. This is contentious because which one is better is, there's two camps. There's people that like a nice clean linear history where everything gets squashed and there's just each merge is one commit in the main or trunk branch. Or there's people that don't care if you see all these networks, connections and nodes and history, and that everything's messy because development's messy. So I'm fine with a hot mess. If you're not, you'll want to do opposite of this and adjust the CI/CD accordingly. So we've got that set up. That's all we need to do in GitHub to kind of enforce our kind of workflows. We see develop here is the default branch. There's that feature penned environment branch in main. And I've created this new HyP branch, which we'll actually kind of recreate, and I'll show you how it goes. So back to OpenSAR Lab. So we've got, I need to do git remote set URL origin. So origin was the ASF OpenSAR Lab wetlands notebook. Because I want to work with my fork, I need it to actually be my fork now. So I'm just going to change origin to point at my fork. Did I spell? I spelled it wrong, of course. And I'm going to get fetch all and then prune. So that'll just get all the branches from all of the remotes. I only have the one, so it'll just be origin. And I'm going to remove any branches that don't exist upstream from my local. So you can see master got deleted. And I've got my HyP branch is the one that's new and main. And if I do my get tree command again, I can see we've got develop, origin main. My master branch now is the same as origin main. You can see it directly right here. So I can fix that by just moving my branch to main. You see it again. Now everything's all synced and everything looks like it does upstream. So we're gonna create a new branch, which is git switch, create a branch. We're gonna call this like we were doing a HyP plugin for wetlands, so I'll just call it HyP Wetlands. Give a nice name, and I want to start from origin development. So I'm actually tracking origin develop here, but we'll fix that in a little bit by doing it this way. But I'm on HyP Wetlands branch, and I'm in line with origin develop. So we can start from here. So this is the part where we'll start with the cookie cutter. So the cookie cutter is pretty easy. All you need to do is have cookie cutter installed. I have my base conda environment activated right now. You should generally avoid installing anything into base ever. It's less of a risk in OpenSAR Lab because the base environment gets blown away every time and like recreated back to the original version every time you restart your server. But I still wouldn't recommend it. So I'm just going to create an environment just for the cookie cutter tool. So I'm just going to do Mamba and Mamba create. I don't need the M. That's name cookie cutter. And then it uses Python, and cookie cutter is the package. It helps if I can spell. So now we just need to activate that environment really quick. It's a good practice to deactivate whatever environment you're in, and then activate the new one. Otherwise, you get stacking environments, and you can get some weird path and dependency fun that way. So I always just Mamba deactivate and Mamba activate. Cookie cutter out of practice. All right, so now we can run our cookie cutter. So I dropped the link in earlier. Sorry, I gotta hide my video panel so I can actually do things. So HyP cookie cutter is in the ASF HyP org. It's got a README walking through how to run it. Like I said, these instructions are assuming you want to create a brand new fresh Git repository. So we'll adjust these instructions just a little bit. And then I'll show you what this does as we go through it. So I'm going to do cookie cutter, and then the link to the cookie cutter specifically. When I run it, it'll say, hey, you've used this cookie cutter before. Do you want to re-download it? Yes, it doesn't matter. So because we're setting up a bunch of CI/CD actions, there's a couple of them that require an actual user and user token. So if you're on a team, you might have a team account that you use for this, a shared bot account effectively, or if you're on your own, you might use yourself. So I'm just going to use me, my GitHub handle, and my email address that I've got connected to GitHub. And then we're doing some wetlands annotation mapping with the notebook. So I'm just going to say the process type we're doing is wetlands. This will just kind of help fill out some context in the Python package that we're creating and the Docker container as well. And if we wanted to be fancy, we could look at this notebook and use kind of the same title here. So this is a HyP plugin for classification of wetland inundation extent with HyP. Or sorry, not with HyP, with NISAR data. Terminal is being weird. So we're just going to go ahead and do that again. And then, so our public URL, so this is assuming you're creating a new HyP plugin in our HyP organization and following kind of our normal HyP dash thing naming convention. That's not a requirement. You can put it in anywhere. So you just want to paste in whatever repository you're already using here. And this will add a license file that has a copyright. So you can specify the year of your copyright there. And so this is kind of just the things the template needed. So let's see what the template did. And then things will start to make more sense now. So we've got our wetlands notebook that we open. So there's some changes and a checkpoint for it. And then we have this new directory called HyP wetlands. So in the cookie cutter context, this would be the repository directory, the top level directory of a repository. So we would next go CD into it, get init, and then push that to GitHub. But we don't want a new repository. We just want everything injected into this one. So we're just gonna do a move like wetlands, and I'm gonna use a brace expansion because we want to move the dot files as well as the normal files, and move won't touch dot files or hidden files by default. So move everything that's in there up to our current working directory. It'll give some warning about how it can't move itself or its parent to itself, but that's fine. You can ignore that. And if it worked, we can rmdir remove that directory, HyP wetlands. And so I was able to do that, so there was nothing inside of it. And so now if we want to look at kind of what was created, I'm going to use the tree command because the directory viewer here doesn't show dot files and it's small text. So I think it'll be easier to use this tree command. It doesn't come by default with OpenStarLab. You have to sudo apt install it, but you can do that just fine. So it gives you this pretty print of the directory tree we're looking at. So what happened was we started with this file and this file, the environment YAML and the NISAR ADB, and then we just dumped a whole ton of other files into here. So let's just go through what those are. What we're going for effectively is the Docker file. We want to build a Docker container that wraps this notebook that we can run in the cloud. There's some niceties that are in here that we encourage. A changelog is a really good habit to get into. To every time you release code or even make a pull request, record what those changes are so you can go back in time and see them. This is kind of a human readable for your users or yourself later type document that's more descriptive than just reading the Git history. And thank you, Alex, for the links in the chat. Okay, so and there's a code of conduct. This is kind of another nicety thing. This tells people who interact with your repo that they need to be nice and not be a jerk. And if they're a jerk, you'll ban them. And then a license file. HyP products use the VSD3 license by default. It's a permissive use license, so anybody is free to use your code, fork it however they want, that kind of thing. So you can adjust this license as needed to match. And I actually am not sure what the NISAR ATB license is. So we're going to go ahead and RM the license file right now. And that's a circle back to later sort of thing. And then the other thing is this pyproject.toml and manifest.in. These are files that say, hey, I've got a Python package in here. That Python package is this whole set of code. And what the Docker container is going to do is it's going to run this script, which we'll call this package's main function. So to add our algorithm, our notebook or script or whatever to this cookie cutter, we've set it up so that main provides the nice Docker run command line interface, and process.py runs whatever you want to stick into it. So I'll show you how that works in a bit. And then being nice, we want to have some tests to make sure things work. So the only thing that really happens right now by default is that this main py file exists. So we're testing that with this test. So when this thing gets created, we're set up. There's just one cleanup thing we need to do here, and we have a perfectly working minimal plugin, which I'll show you. So the container dumped an environment.yaml with a YML, and we started with an environment.yaml with a YAML. So Conda convention and tools like Binder and whatnot use .yml, even though it shouldn't really matter. So we're going to go ahead and move everything out of this environment.yaml into the one that was created. So that's just dump all the stuff for running our notebook into the for running section. It's nice to alphabetize this section, so I'm going to move HyP3 down. Click on my white space. And then we're used to using this environment. We've already created it, so let's keep the same name, not the brand new name created there. So we have this environment YAML. We can delete this one. This one will take precedence. So then, oh, and you have to explicitly save with Jupyter Hub. Now I'm going to get rm environment.yaml with an A. Get add environment.yaml. If I do get status, you can see I'm a terrible speller. All it thinks is I just renamed it. So we took precedence, we renamed it and updated it sort of a bit. And now there was some stuff that was added into our environment. So there was rough for linting and formatting, and then some stuff to help build the packages and PyTests and some things to run the Python tests. So we're just going to want to update our environment. The easiest way to do that is to do mamba m update using the environment file. Update's actually a really handy thing to know. Update will also create an environment if it doesn't exist. So when you come into a brand new repository, you see an environment file, you can just type mamba n update-f environment.yaml, it'll create it and everything. And then every time you come back to it and check out new changes, you can just run that command again, make sure everything's up to date. So there we go. And then now we're gonna deactivate, activate our environment. At this point, it would be a good idea to go through and make sure our notebook still runs and that the environment still works for it. But I'm going to actually go ahead and skip that. We'll go we'll circle sort of back to that. I want to keep talking about what we've created here. So I've got this, there's wrong tree. So let's start talking about kind of how we've set up the Docker file and this Python package. And there's some edits we'll need to make kind of here. So I can close the environment file. Actually, I'm gonna leave it open for a sec. And because I'm gonna want this name. So the first thing to look at is the Docker file. So I'm just using the Conda Forge, Mamba Forge latest Docker container to build this Docker container. HyP does not care at all what Docker container image you use. The only thing we care about is that you provide an entry point. So this is this thing down at the bottom that provides a Docker run command or a way to do a Docker run. So you can do whatever you want inside of the container. You don't have to follow our, like, you don't have to use this image. You don't have to follow kind of our standards. The reason I've used this image is that it makes it really easy to create a Conda environment inside of it. So what's happening with the Docker container is the same thing that would happen locally on your computer, and it's the same thing that's happening on OpenSAR Lab. So everything should act and feel and look the same, whether you're in the cloud, whether you're on your computer, or you're in OpenSAR Lab. This is just some metadata to help understand kind of what's going on. You can see our description that we typed in here is shown there. The addresses, I actually deleted the license, so I'm gonna go ahead and delete that and not report the license. And it links to our repository, and if you wanted HyP documentation, it's there. I have a typo in my cookie cutter. So these two things here in the Docker file are just things that make building the Docker file easier and smaller. The Mamba Forge image is based on Ubuntu. So if you're familiar with Linux, what we're doing is just installing a couple niceties, the unzip package and Vim, so that if you're working in the container, you can actually edit files easier. And then we're gonna, when we build the Docker container, it builds to a specific user ID and group ID, because we don't want to run as root. By default, it would just be 00 for root. So we're actually adding a non-root user and setting that up. And so we provide these arguments so you can set these. By default on Ubuntu, if you did a fresh installation, or most Linux systems, you're going to be user ID 1000. If you're managed by somebody, like I was handed a laptop from ASF, the system admins are usually this default, and then I'm like 101 or something like that instead, or 1001 instead. So we provide build time arguments to adjust that. This is one of the fun edges. For the most part, you can just ignore it. So what we're doing is adding the user, and then we're gonna create a Conda base environment and activate that base environment by default for that user. So now we're going to switch to everything that's happening after this is by default that user, not root. So this is a security measure. So this is all sort of set up for you. The user is going to use a login bash shell, and their working directory in the container by default will be this home/conda directory. So we're going to copy everything from the local directory where we're building the Docker file to this like wetlands directory. This actually doesn't make sense here. This is typically the repository name. So I'm just going to rename this wetlands notebook to make it clear. We're just injecting this repository into the Docker container. From that location, we're going to take the environment file and create it. So we're going to create the environment using the Mamba env create. We're going to clean up anything that's cached and delete all the extras because we don't want it. And we're going to activate our environment, but it's not called that, but it is called this. So let's fix that. And then we also want to activate that environment by default. So instead of base, we're going to activate that one when we jump into it. And then we want to install our package. So I haven't shown this yet, but I will show it to you in just a sec. And then, so that fixes all of those. So the Docker container is going to, when we run Docker container, it's going to run this script. So let's have a look at that script. It's in tests, not tests, in source. If I could type wetlands, etc. entry point. So this is just a shell that when Docker runs the container fires up, and then it runs this script that says, hey, I want to be in a login node. I want to activate my environment. And then I want to execute Python-m type wetlands with any parameters that we've passed to Docker. So this is going to be what happens when you run the Docker container, and it's going to be what happens when you run the Python package, and it's going to be kind of how we're going to execute our notebook. So we made all of those changes, and I can do a rep -r and so I just want to make sure that I got all of the HyP wetlands things, because this is the name of our repository in Conda environment by default from the cookie cutter, but we actually have different names for this. And for getting save, we get a bunch of checkpoints. So if we ignore the checkpoints, oh, this search through all the get, but the only thing that we have here are our get history things. So we're okay, we've done all the edits that we need to do. All right, so let's see actually how this works. So we can do Python. So we've got our Conda environment, it's activated. Now we need to install this package, this HyP wetlands package that was created for us. So here's this HyP wetlands package that the cookie cutter dumped in, and that's how we're going to invoke whatever we want to with our Docker container. So we can do Python-m pip install. I'm going to make it editable or a development install. So if I change a file, it'll automatically be reflected in the environment. So it just links to the files that are locally. That means that I can run something, tweak it, run it again, and see those tweaks, and just install a local directory because I'm at the repository root. So it's going to check all the dependencies, see that we already have them because we're managing them with Conda, and it's going to get installed. So that means that I can do Python-m HyP wetlands help. So I now have a Python package that when I execute runs this main script that gives me the minimal HyP interface. So HyP plugins always assume that you're going to upload something to a bucket or bucket prefix optionally. So when you run in HyP, all the output products need to come out of the container and get stored in S3. So we set up that mechanism for you, and it provides us arguments. And if we were going to run the Docker container in the cloud, then it looks exactly like Docker run. If we pushed it to GitHub container registry, IO / and it'll be JH Kennedy / wetlands notebook. And then test, right? It would look something like that. And then that would execute this Python-m wetlands, and anything we passed after it would get passed to that thing. So these calls are equivalent right here. Run my package, Docker run thing. So we haven't actually built the container yet or pushed it, so this won't actually run. But this is kind of the mechanism we're setting up. so that you run the container and it looks exactly like running the Python package. So what the Python package does right now is just writes a greeting. So, well, maybe that's jumping ahead. Let's have a look at our get status. We've got a bunch of stuff. We want to add all of this stuff. So that we can see where we're at. So this is a minimal kind of plugin. We've made the editing changes we want. The plugin runs, it's installed. We can also, because it's installed in the environment, run PyTest. It'll check text to make sure that that entry point script works. So it'll test to make sure that python-m labs works. So that test is just running that command. So we have a testing infrastructure set up. We have a Python package set up. Python package really doesn't do much of anything. All it does is writes a file to disk. So if I just run the package, you get status again. All I did is write this greeting file to disk. If I look inside, it's just saying, hello world. So this is a minimal kind of just, it does something, it provides you a file, and then that file could then be uploaded to S3 if you provided access keys and the bucket and bucket prefix parameter. It also provides a command line message to, or command line argument to change that greeting. So I'm going to do some bash magic because I don't like that this didn't produce a command or a new line character. So it ended up clobbering it on the same line as my console. So I'm going to actually say, hello, NISAR, the documents. And really doesn't like this overrunning the console. So I'm just going to not. So now that argument instead wrote, hello, NISAR. And because it's weird about overwriting the console, going to a new line, there was a little bit extra in there. But this got passed, and the brace expansion with the $sign here allows this /n to be interpreted as a line break. So that's how I got my nice line break at the end. Okay, so we have this minimal Python package. We have a Docker container that can build from it. And we have a bunch of CI/CD infrastructure. That's all this GitHub stuff that was just created for us. So let's go see how that would look. So right now we've got to commit the minimal package. I'm just going to say add a minimal type plugin with cutter. I set up my sign-in keys, so I have to add my key. So we got a new commit, and I can push this to GitHub. I push it to, what did I call this? Git push -u. I didn't set my remote tracking. Oh no, it's because I've got the order backwards. But I want to push upstream and track origin wetlands. So now that I've done that. I'm no longer tracking develop like I was before. I'm tracking the new branch that I just pushed, that U flag. And if I do get tree, again, we see we've got this new commit, HyP wetlands, that was pushed upstream to HyP wetlands. And Git is smart enough to see that we created a pull request, or that we pushed it to GitHub, so we can open a pull request and see what happens. So this is how we'll start looking at our CI/CD. We want to add a minimal plugin. So this, when we first open it, because we're on a fork, we'll assume we want to push it back to ASF Open SAR Lab wetlands, so the parent. I actually don't want to go back there. I'm just going to stay in my own fork, and the master branch isn't the one we want. We want to go to develop. So GitHub's really weird about working in forks. They assume that you're always going back upstream. So it's very clunky to work directly inside of a fork. If you're going to work in a fork a lot, you might want to disassociate it with the parent, but then it makes contributing upstream harder. So the trick, the annoying trick in GitHub to do it is actually to fork the fork so that your contributions are going to your fork from your forked fork. And then PRs work that way. So you use a forking workflow yourself on your fork. It's silly. There's been an open issue on GitHub's community page for like 10 years about that. So we're just gonna go ahead and create our pull request, and we kind of review what happened here. So pull request is started. There's no conflicts with the brace branch, and a whole bunch of stuff just happened. So we see all of these checks started to go. So we've got, we can go up here to the checks tab and we can see kind of what's going on. So we've got test and build. So test and build right now we'll call PyTest, and it'll check 3 different versions, Python 3.10, 3.11, and 3.12 to make sure it works. Testing multiple versions isn't necessary unless you're building a library you want to distribute to people. So if we were just building a single application that goes in a Docker container and goes to HyP, and that's the only usage pattern you expect is via the Docker container in that specific environment, you can skip testing on multiple environments. If you're expecting users to pip install or conda install the Python package that we created to facilitate this Docker to your algorithm thing, then you'll want to test multiple versions because you won't be controlling the environment that they'll be installing into. So we sort of always take on the HyP team a library first development. We expect everything is going to be a library so that it can be reused. So we set up that kind of structure implicitly. So this is going to set up our conda environments, run the test there. When the tests are done, it'll build the Docker container as well. It'll also do some static analysis. So it'll check to make sure the changelog is updated. So there's a new changelog added. So this is a way to remind you, hey, keep track of your changes. So the changelog looks like this. Just says all notable changes will be kept here. We use this format. So for version 0.1.0, which is unreleased right now, this is what's coming. So we haven't released yet. Anything that we add, we could just describe here on our first release. This is a plugin to provide wetlands inundation, blah, blah. That would go there. Here's our code of conduct. Looking around at this, GitHub is giving a warning about this code owners file. So code owners is a good way to automatically request reviews. If you're in the HyP organization. That's where your plugin lives. This will at anybody who wants to be a plugin maintainer. So this is a team. This team doesn't exist in my fork, so we can actually go ahead and just delete that file. Can't figure out how to get rid of this thinking zoom panel, making navigating hard. That file is in the .github directory. Git rm .github. Push those changes so they show up in the PR. So if I refresh, that file's gone. We're not being complained at. So we can look back at our checks. You can see when we push a new one, new checks all start running. That's what's shown down here. But you can see the old checks here. We can see that all of our tests were working for all the different versions. The version, and then it's trying to build the Docker container for us. So the beauty here is we tried to build a Docker container here. We can't, there's no Docker here. We're running in a Docker container in a Kubernetes cluster in OpenSAR Lab. Docker and Docker is kind of a weird thing. Sometimes you can do Podman instead to do it. Those aren't available on OpenSAR Lab. We can't build a container here, but we don't need to. We can just let GitHub do it for us. So we've kind of set up that pattern with the CI/CD. So you can get additional resources and everything with CI/CD. And then we want to go back to our actions. We can see more actions running. So here's the test and build. It's running through Docker. So it's building, it's trying to build. So it's towards the very end, it's installing the environment. So it's working on actually building the environment in the container and installing the Python package. So this will take a few minutes. The Docker builds are slow. The Docker files are large. They're often gigabyte sizes when they come out, especially when you're using packages like NumPy and GDAL. There's a bunch of optimization you can do for Docker file sizes. Generally, that's an optimization that's not a big return on investment until it's drastically needed. So we're just gonna not worry about that. So looking ahead, I know that this Docker build is actually going to build successfully because I've done it already in a different PR by cheating in a HyP branch that I had done earlier, build a minimal PR. What's going to happen is if I look at the checks, it's going to look like the test and build that the Docker container was built. If we look, it did successfully build it. Blah, blah, blah. So we got successfully installed, done, happy. but I got a warning, no push. So what we did in this workflow to make the workflows fork safe is that a fork won't have permission to push to the upstream's orgs repository GitHub container registry. So you won't be able to push the Docker container upstream. So we turned off the push so that when you're in a fork, it doesn't push. But that doesn't actually help us here. So the way to fix that is actually going to be to open a PR upstream. That container, when it's pushed initially, will actually be private. GitHub makes sure that all the packages you push to its registry are private initially, and you'll have to go into the settings and click no, actually make it public. So we can either adjust that workflow to push locally, or we can try to push it upstream, sort of a thing. Or because everything works kind of anywhere you want to be, we can go ahead and actually just do this locally. So I'm just going to build a container locally. So I'm going to show you how that works. So we're going to have to, I'm going to open a terminal. If I can get one. So I'm on my local machine. It's an Ubuntu machine, so I'm on Linux. I clone my notebook into here. You can use Linux or Mac or Windows. There's various levels of pain depending on which operating system you're on. Most everything in the cloud is going to be running on Linux. You'll have an easier time doing cloud stuff in Linux. Mac is a good option because it's kind of it has BSD on the back end. It's Linux-like and lets you build stuff. But most modern Macs are ARM architecture, not x86 architecture. So you're going to get containers that are built there won't run on Linux systems unless it's an ARM system. So there's actual like underlying system architecture problems. So OpenStar Labs in Linux, we're going to use at HyP just a normal Linux AMI. So it's beneficial to be here in Linux for this. You can use a Linux VM if you're on a Windows system, or the Windows subsystem for Linux sometimes works well. So I've cloned the repository, moved into the wetlands notebook. I'm on the develop branch because, here, let me increase the font size for you. Yeah, remember how to increase the terminal font size. Okay, let me get a different terminal that works better. Here we go. Here's terminal. And now I can zoom in a bit better. So we're here. We want to switch to our branch we were working on, which was HyP wetlands. And because I'm on a new machine, I'm going to create my environment again. And the continued pattern is I can't spell. And I'm going to run this Docker command, and then we'll take a break after we see how the Docker container works. And Conda package repository is not working. Looks like it's gonna go anyways. So we are right at our scheduled break. So maybe let's let Honda churn over the break and we'll come back in 20 minutes and we can run through the rest of the Docker image, injecting the environment or the notebook into it with PaperMill, and then just talking about how we might rework the notebook and the package to follow some kind of best practices. How does that sound to everybody? Getting at least one thumbs up. So I'm gonna mute and stop my personal video, and stop sharing my screen for the break. So reconvene in 20 minutes. Okay. So we can jump right back in. I am actually having quite a bit of trouble with Conda or Mamba locally. So I've gone ahead and got Alex and Dylan to give me access to the original repo as a maintainer. And I've reopened my PR there. And so we've got our tests running and our Docker container build running. And this should allow us to push a container and then pull the container from here. Unfortunately, this action will, oh, it succeeded. Let's see, let's have a look. I expected it to fail. Build, Docker container, build and push. And it pushed to this. So here is our Docker container. I'm going to put it in chat. It's going to be private, so you won't be able to pull it yet. And then we can go to Wetlands Notebook, back here. And I can see packages right here. So we have this Wetland Notebook container. It tells you how you can pull it. If you have it here, and I need to go into package settings, and I can change the visibility, and actually the package is public, so you guys could pull it if you wanted to. So we're good to go. We've created a Docker container from our repository, and now we can pull it. So that looks like, let me get a terminal up. So I'm on my local machine. I want to pull that container image. Take a couple minutes to pull everything. at my door. So need to do that. So colleagues don't hear me rambling. Okay, so I have my container, and now before we could run Python package with python-m, type wetlands, help. I haven't been able to create the environment or install it locally, so that command's not available here. But I can do the same thing, which is Docker run, and I'm just going to add a couple Docker flags to clean up the directory when it's done and set it up for an interactive run. So here's my Docker run command saying run this image and just do the help. Oh. Let's do this. So it could not find the environment inside the container. So we can actually go ahead and jump into the container and see why. So now I've jumped into the container, and instead of using the normal HyP entry point that we installed, I'm in as in just a shell. So there's nothing in the Honda or the directory. So I'm in home Honda, that default work directory we had set up. There's nothing here. There should be something in wetlands notebook. So I see it there, source, etc. All right, wetlands in my package. So there's our shell script, it's executable. So that's what our entry point tried to run. If I run it, it goes, oops, need to run conda init before conda activate. And I can see that the environment is there. So it tries to activate the entry point, but the conda setup isn't quite right in our file.
So it looks like it was looking for an environment called Wetlands Notebook, but the environment's name is NISAR EA Workshop 2024-10.
Yeah, so let's see if that is probably an issue in our. Is that in the Docker file or the environment file? So it should be activating that one. And in our entry point, oh, yeah, it's trying to activate the packet or the repository, not the environment. So that's the typo right there. So we can fix that. Status. Docker entry point. Push that. And then our pull requests. Yeah. Push. Oh, I'm on my fork. What? Here we go. So it's triggering, things are running. So this will take a few minutes to get the package tested again and the Docker container built. The drawback of CI/CD is that you have to wait for it to run. That's okay. We've got a container here. We can fix the entry point shell script. Let's see if we did it. Let's just go ahead and add Vim. And this is why we added Vim, so that we could jump into the container and do these things. Then now if we run our bash container with the help, or their batch entry joint, the help. Oh, it's still gonna complain because I'm in a login shell. Let's look back at our Docker file again. So that this right here should be what Conda is doing to activate, and it should already be in our .profile. So when we run the entry point, this should work. So locally, there we go. So if we run .profile, which gets run automatically as part of that entry point, it does give you the right Python environment. Then that means we can run our entry point shells. Well, we can't. We have to use the login shell. So in our Docker entry point, we had a bash dash, or in our Docker file, we said run bash as a login shell. And so that's the difference from what we were doing in the container. But when we do bash as a login shell entry point, we get the thing that's the same as doing Python m pipe wetlands help. So we get the same sort of thing. We run it without our thing. We get our greeting.text. So everything works the same in the container as it works locally in OpenSAR Lab. And if your Conda environment will build because your computer's not borked locally, it'll work the same on your local computer. So everything should work the same wherever you are. Okay, so at this point, we've made effectively a working HyP plugin. The only thing that it does is writes a greeting message to a file, and then if you provided S3 keys or S3 bucket and bucket prefix and the credentials to access that S3 bucket, it will upload it to that bucket. So let's actually go ahead and have a look at how that works, and then we can see how we would inject our algorithm into this plugin.
And hey, Joe, there's just a question in chat. So when we rebuild the Docker image and push to the registry, it pushes to the same registry, right? It doesn't update the registry.
So that's a good question. When we look at, so we've set up a couple things. Here, let me get back to the container. If I want, so I'm going to just jump into Python. If I import pipe, but this is a roundabout, I am answering your question, but you'll see why. import HyP wetlands, and I print the HyP wetlands version number. You see that it's got 0.1.dev5 plus this. This is the git commit hash. So if I'm back over in OpenSAR lab, I do my git tree. I'm on, so there's that 16570D2. Oh, that's not quite the same one because it's built differently. But what's happening is the Python package, because this is from before, the Python package it's implicitly using the git tags and the git hashes to give you a version number. That's the version number for the package. And then in our CI/CD pipelines, we also tag the Docker container that way. So we go back to our repository and packages. You see that same number right here. So you can always go exactly to the Docker container that has the exact package version you want this way directly based on the tag. So next time we build, it's going to push a new version, so a new tagged image. And when it's done pushing, you'll see 0.1.dev6, there's a new commit. So it's been another commit from the 0.0 version, and here's the git hash. So you'll see this new version come up. So these are great ways to explicitly say, I want this exact version down to the commit hash of this Docker container and package to run. It's not very easy for deployments. Every time you wanted to change the package, you'd have to update your HyP deployment. So we run over to our burst processing plugin, HyP2. If you look at packages, what we do is we also tag them, some of the versions, with this test tag. I don't know if you can see that. There we go. Test tag and latest. So Docker convention is latest is the latest stable release. So if the CI/CD built the Docker image from the main branch, it would also tag it latest. And so that would be the latest released version. If it built the container from the develop branch, it would tag it test. So that's the test version of the container. And so anytime you merge a PR to develop or main, it builds and updates that container and tags it with this test. And so these two tags migrate. So after the PR is built and all the actions are done, you can you're automatically deploying that Docker image if the AWS infrastructure is pulling in based on those moving tags, if that makes sense, or you can pin to specific versions. So yes, we will see a new version of the Docker container get uploaded here. And because we haven't merged to develop, we don't see a test or latest. So there it is. Here's our new version. So we'll just go ahead and pull this one locally and exit out of that. Docker pull. It won't take as long to pull because a lot of the layers will be the same. It's only a little bit of changes at the end in the package now. And then we can do our Docker run. And now we should see it work. Hooray! So now we have this working container image, working plugin from that branch. If all we were trying to do is just stick a minimal plugin in there, this would be a great time. This is a nice small increment to go ahead and get a review, approve that PR, and merge it in. So we could do that right now. The next step is going to be, let's actually stick the notebook inside the plugin and execute the plugin with a tool called PaperMill. So we'll just go ahead and do that in the same PR. So PaperMill, I'll drop into chat here, is a tool developed by Netflix initially, I believe, to make executing notebooks a lot easier to do kind of on a large scale batch type system. So their data scientists could write these notebooks that they were familiar with, but really not have to think too much about how you actually run the notebook on infrastructure. So this is a way for data scientists to focus on what they're good at, the science in the notebooks, and give DevOps engineers an ability to take what they've developed directly and run them at scale. So we can leverage that here. So how that works, we'll go back to Jupyter Lab and we'll hop into our HyP wetlands package. And so we'll actually look at kind of what's happening now. So in main, that was actually, that's the best way to do that. Increased better. It's having no effect. Okay, so we'll just do that. So in main, what we're doing is we've got HypeLib. So this just provides helpers to upload files to S3 and create a thumbnail image if you had a product that provides a thumbnail image. So like a geotip. You want to provide a nice little thumbnail image so you can view it in a browser easily. So all that, like the main entry point's doing when you execute Python -m package _, it runs this main function or main Python script that runs this main function that just sets up the argument parser. Here's our bucket and prefix, and here's our argument, the greeting extra argument. So this would be where you would add the things that you want to make arguments to your notebook. So we'll talk about that sort of at the end. Parses those arguments, and then it calls this process wetlands function from wetlands.process, passing in those arguments that you set up. And then at the end, if you provided the bucket argument, it'll try to upload that file to S3. It'll try to create a browse image. This will break because we're making a text file. So that won't actually work. And then it'll upload the browse and thumbnail images to S3. So the browse images assumes you're writing something .png, and then we'll create a thumbnail from that browse image. So the way process works, there's just this, there's a main script, so you could call this directly. So we can register this as a command line entry point if we wanted to as well. You can actually ignore it. This is the function that's being called on from main, right? Process wetlands. So this is the function being called here. So what we want to do is actually, we don't care about any of this. So we'll actually just drop in a fix me. Remind us to come back to that, and then we can give us a script of what we're going to want to do run notebook with PaperMill. So that's what we want to do right here, and what we want to return is actually the executed notebook for now. So what we're going to need to know is a path we need to know where the notebook is. So this will be a path. And we'll have to figure out this later. And then here is how we would execute PaperMill. So PaperMill is pretty easy to install. We're just going to install it by putting it in our environment. And PaperMill. And then we'll do a Mamba and update -f. Hold on, I'm gonna have to save this explicitly. We could also condo install PaperMill, play around with it first, and then if we're happy with how it's working, add it to the environment file and up so that it gets updated that way. Find it easier to remember to keep the environment updated if you just do it explicitly up front and use the environment update command. It takes slightly longer to build the environment and solve everything that way. So we saw a bunch of stuff come in. PaperMill is there. And now we should have PaperMill. So there should be a PaperMill CLI executable. That gives us a whole bunch of utilities to execute a notebook. And right now, the way everything works is our notebook is at the repository root. But the Python package and everything is in source wetlands. So we're actually going to want to move our notebook somewhere inside the package so that if you install the package, the notebook comes with it. That will make it a lot easier to then reference the notebook from the thing. So we will go ahead and do move. Let me close the notebook. Do that. So there's our NISAR HyP wetlands, and we're going to move it into source HyP wetlands. And I'm going to just put it in the etc. directory because it's not really a Python package itself. So it's in there. We've got our modified environment and the process stuff we're working on. So now we can go PaperMill. I believe we want to do notebook will be source wetlands. So there's our notebook, and then we want to specify an outbook. We're just going to put an out location, and so NISAR HyP wetlands run. So we'll just do this for now just to make sure it works. So we're getting a no such kernel error. And that is because it's looking for that kernel. So let's go ahead and open up our notebook again. Oops. Make sure they run. So here's this issue we ran into yesterday. Dylan, maybe, or Alex, you want to drop in the change to make here?
Yeah, so there shouldn't really be any changes required there.
Well,
The
we need to
oh yeah,
unsign.
I guess we're not doing requester pays. Oh, so if you aren't going to do requester pays, then you should comment out the NISAR Calvel Public West 2 bucket and just stick with the ASF Jupiter Data West.
Ah, okay. And then I could just delete requester pays, or do I need to add unsigned?
It might yell at you if you don't provide an unsigned config. Yes, it does. Hold on one sec.
Yeah. I can figure it out in chat, but I don't.
Okay. I'll drop something into chat for you.
Either way, so at this point, we know that the notebook executes in our Conda environment. The imports all work, first cell works, second cell bonk, so we should still see PaperMill run. So we have to figure out how to tell PaperMill what kernel we want.
So I just added the some code to chat that sets up the unsigned config.
Sweet. Okay, yeah, so our notebook's running. Let's do this later. So we can pass this K, the name of the kernel to run, so that it ignores the notebook metadata. And when we ran, it was looking for kind of the conda local blah 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 kernels. I think. Let's see. I think it's just the name of the conda environment. Nope. So now we have to figure out which kernels are available. List. So this kernel, the way PaperMill is going to understand it, is actually going to just be called Python 3. NB conda ems is smarter. When it registers kernels in Jupyter Hub, it names it after the conda environment. When you install a kernel in a conda environment by default, it's just named after the Python version. So you just get Python 3. So in the package and the Docker container, And the conda environment, the kernel actually looks like it's just called Python 3. So now it's running the notebook. Take a little bit to execute all of the cells. Takes a few minutes to run the notebook. But now we have an executed notebook that just dropped into our home directory, which I opened the executed one. Let me close some of these files so you can actually see the file name fully. So now we have NISAR HyP3 wetlands _ run. So we created the notebook. You can see the outputs are all there from running it. Scroll down. You get the images you should have seen already and are familiar with. And saved. And classification image and histograms and all of this kind of stuff. So now we've programmatically executed this notebook using PaperMill. So now we just need to pipe this into our Docker container. So that go back into our package. To process.py. We got our notebook path. Now we set that up inside the package so we know where we are in process.py. So we can use path with the _ file to figure out where this process.py file is, no matter where we are. Get its parent, so this is the directory that it's in, so HyP _ wetlands, and then etc. It's the directory that we put it in, and we just want its name. We could have just copied the whole that easy. So this is relative to this file, so it's going to be easy for the Python package to find it. So there's our notebook path and our executed notebooks. We're going to want to take, we'll also use the path function. We're going to just stuff the notebook into the current working directory. Spelling grammar leaves on apparently. One more grammar. Okay. So current working directory, and then we're just gonna call it notebook @stem. So that's this part of it. And actually, let's add some stuff to it. So there's HB notebooks. We have done it as run. I notebook. But we actually probably want this to really be now. So we're going to date time, import date time. Now. So that will give the time that notebook was specifically executed, or right before we called it to execute. And then for PaperMill, executing it, it's pretty easy. We do import PaperMill as PM, and then execute the notebook. We're actually not passing parameters right now. Don't have to worry about that. This is path to input notebook. So this is going to be our notebook. Whoa. Notebook path. And executed notebook. And then we will probably want to specify kernel, which is kernel name equals Python 3. So that was the same thing we did on the command line. And then from this process wetlands function, we just want to return the executed notebook. So this is the path to that notebook. So back in our main function, what we're getting here is executed notebook. We left this in so we can sort of ignore that. So we want to upload our executed notebook to the bucket and prefix. And we don't have a browse or thumbnail images, so we can just not worry about those. And I don't need to import the thumbnail image. So there we go. This should technically give us a minimal HyP plugin that runs that notebook. So I'm going to add the changes we made to the environment to source like wetlands, process.py, source wetlands, it's NISAR. And these are all just data that the notebook dumped out. So we don't need those right now. So we can just kill that one and clean ourselves up. I added that one. Okay, so we have staged the kind of minimal notebook changes that we need to make. So now let's try executing it via our normal kind of entry point. And actually, I'm just going to Control C that. Yes. Because I want to clean up the output file so we can see the new ones show up. We're completely clean right now. And we can run. And we see that it's gonna output the notebooks to the current working directory where we're at. It's running PaperMill with the Python 3 kernel. It's executing the notebook and going through. So now when we commit this push, the Docker container will get built and it should also be able to just run this notebook. So at this point, we have a HyP plugin that runs the notebook. So this is how you can quickly and easily build stuff in. There's cleanup we'll want to do. We left ourselves some notes about that. We remove our to-do. Probably don't need to write this greeting.txt anymore. We're not taking this command line argument. We just don't need any. Saying what we're doing. Don't need any of this. And then back in main, we're not using greeting argument anymore. We can just delete those. And there, we're all cleaned up. The other place that we might want to check, because I deleted that main and process.py, is our pyproject.toml to see if we registered an entry point. Have not, so it wasn't being used at all. Okay, so back to our shell, we saw that it executed. We've got the data in the current working directory. We've got the NISAR ATV notebook right here. And we hadn't deleted this when we executed it the first time, so there's also still the greeting stuff text. And then if we open up the notebook that was run with the name of the execution time, we can see we still get all of our nice figures and everything saved in it. So we've got what we think is a working plugin. Add source, commit, and modify plugin. Push it. And when the Docker container is built, we can confirm that. It'll take a few minutes to do it. Our pull request is open. Where you can review the changes of all the stuff that we've dumped in here, which is quite a bit of stuff that would have taken a lot to build out on your own, that the cookie cutter just handles for you, provides you a nice portable Docker container. So at this point, this is sort of the place to get to run this notebook. So that we can take, I think, the last 9 minutes to talk about where we want to go from here. And then we can switch back to kind of the higher level concepts about AWS and some best practices, and then we can open it up for questions where we can dive into anything. There should be about a half hour of time for that. So let's see, just watch the checks. We can come back and confirm once the container is built that the plugin's working. Right now, the plugin just executes the notebook as the notebook is. There's no parameters and ability to change the input data. So if we look at that notebook, right here, it's something that we would probably want to make a parameter, right? Like this is a hard-coded AOI. We would want to be able to add a parameter that says like dash dash AOI and then the AOI name. So what we do, this. And then we want sweat codes, like, so all of these kind of hard-coded things, these might be parameters that you would want to make. And so that the notebook would then take these, decide what data to act on and what location it is, and then get that data and run it. So that's how you would then take this notebook that runs on this specific location and start scaling it out to other areas. So you need to think about kind of inputs and outputs that way. Right now, a lot of things are hard-coded. The bucket prefix, anything that looks like hard coding things are things that you would want to consider parameterizing. And in PaperMill, it's pretty easy to do it. You take a cell and let's see. Add a tag. I'm trying to figure out how to add a tag. I don't see the option. This was super easy when I ran through it. You using Jupyter Lab, click the cell to parameterize, click the property inspector. Right sidebar double gear icon. Aha, there it is. So then you can add a tag and you want to just call this cell parameters. So when you tag a cell, parameters, Jupyter or PaperMill will look at that cell and then inject whatever parameters you pass it in instead of that cell. So the documentation on that is here. So now that this one's tagged parameters, we could then pass on PaperMill parameters equals. So let's hop over to our process.py. That would look like to override that parameter for parameters equals dictionary. Yeah, so then you could inject this, and this could be something different that you pass in via the argument parser command line option and a function to here to change the AOI. So that's sort of the next step in kind of the notebook best practices, is start taking all of the things that are hard-coded or parameters or that you would want to parameterize and co-locate them in a cell, single cell, so it's really easy to tell what the parameters are, to tag that cell and modify it with PaperMill. The other thing, yeah, as Alex points out in the chat, is that a lot of the high-level widgets you're not going to want to use, because when you execute it programmatically, those widgets will either need to have a nice default value that you want it to use, or they won't be provided input. So that the widgets actually get harder, so it kind of limits the tooling you can use in the notebook doing something this way. The other thing is, if we go back and look at our executed notebook, the images are actually largely the output products you're interested in. And so instead of just plotting these in the notebook, you're going to also want to save these to a file and upload those image files to S3. Ideally, they'll be saved as something like a GeoTIFF, so it's really easy to inspect them, or you could pack them all into an HDF5 file or NetCDF file or something. And any kind of metadata outputs or statistical outputs, stuff that you want to do, you would write the appropriate files as there. And then you can just upload all those right next to each other, and those will show up in the bucket when HyP runs. It's also convenient for users to package everything into a zip file. So you might want to take all of the products that you want, upload them to S3 as well, but then also zip them into one file and upload the zip file to S3. The benefit of that duplicates your storage, likely doubling it, but it means that users who are working outside of the cloud that just want to download everything can just download the zip file directly. They don't have to think about it. It's just click one HTTP link, and then users who are in the cloud or want to directly access products over HTTP have direct access to them too. So all HyP products do that. We upload the internals of the zips and the zip itself, just to make things easy. And HyP Lifecycles products, after 14 days, we delete them, so we're not too worried about the double storage, since we're not keeping things around very long. So that's kind of the next places to go. I think, oh, we're still Docker building. So it's exporting the layers, it's almost done. It'll push here in a second. PaperMill is really powerful. It's a nice way to do these kind of lift and shifts, is a good way to think about it. Take a notebook, make it quickly executable in the cloud in a Docker container, parameterize it with some very minor changes, scale it out. Long term, it's limiting to the notebook. It's because of the types of things you can't use, and it's harder to use a lot of the cool tools and optimization stuff in notebooks. So you may consider starting to take the things that are in the notebook, turn them into functions in the Python package that you've created and install, and instead import them and use them in the notebook, and slowly migrate to an actual Python package. If you look at most of our like first class plugins, the ones that we released to production, we're not using PaperMill in notebooks. We're actually writing full-on packages that have processes, but it's using the same exact structure with the Docker container and the entry point, and calling the specific process that we want to run. So for NISAR tops burst, that actually looks like running this function that's doing the stuff in Python instead of in a notebook. Gives you a lot easier optimization. It loses your flexibility in the notebook. So that's a choice you can make when you kind of develop and kind of slowly work between the two. And if you understand the limits of sort of PaperMill and notebooks, you can build a notebook that works really well here, and scale it out really well. Okay, so now we have our Docker container. It got pushed. See if I can find, here we go. So I'll pop back locally. Pull. Oh, copied that wrong. Let's just go ahead. Go see our latest pull. Yep, I missed a 0. Now we should be able to do Docker run. All right, I didn't provide any arguments. So it just showed the help method, because that was the default that we set in the Docker command. So I'm just going to provide buckets. And just a bucket that doesn't really work or exist, just so that we can watch PaperMill execute, and then after it's all done executing, it'll bonk on trying to upload to this bucket it doesn't have permission to upload to. So there we see Docker containers running locally. It's outputting the notebook inside the container to here. Executing with our kernel. It found the kernel just fine. It's running the notebook locally. We're on my local computer where I couldn't build the environment. So everything's running just fine in the Docker container. So we have our HyP plugin. And because this container is designed to be portable, you could run it on your computer, your supercomputer, your cluster, whatever you want, or in HyP later.